Good morning. So, firstly, very well done over the past 2 days on that conversion between improper and mixed improper, because that's going to help you out long run. Now, today we're looking at carrying on fractions sequences, and some elements of this are going to be easier than others. So, if you come unstuck at any point, please do not worry. Now, if we look at this first sequence, we can see we've got 2 6, something, 4 6, 5 6, something, 1 and 1 6. So, what we've got to do is establish what our missing boxes are. Now, the beautiful thing about this sequence is we can see that we are consistently using the same denominator. So we are going to know that in both of these, we are going to be looking at having 6. Okay, we don't have to worry about anything being different from that front. We're dealing with a denominator of 6, and that's all the way through. We then need to establish what are we going up in, and this is where we need to look at the patterns where we have 2 next to each other. So from 4/5 to 5/6, what are we doing? Well, we are adding 1. In theory, we are adding 1/6. So I know that if I'm on 5/6 and I add on 1/6, that would give me 6/6, which some of you would know you could also write as 1 whole. Apologies about that. You could write as 1 whole. So 1. So down here, if you have 4 6, now to go back to this one, you could take away a 6, or you could add a 6 onto 2 6. Either way you do it, you realise you would have 3 6, and that's how this one works. Okay, we know we're going up in a 6, therefore we can help ourselves on that front. Now on this second one, you can instantly see the problem we've got. And the problem we've got is that our denominators are different. Now in a couple of lessons time, we're going to be looking at how to convert and get denominators the same. So actually, you should remember from when we were looking at equivalent fractions. So if we look here, we can see we've got thirds and we've got 6. The one thing we should do is consider what is the similar. And we know that thirds can become 6. So what we could do, we could make this 2/3 into 4 6. And we could make our 1 and 1/3 into 2 6. So suddenly, instead of having thirds and 6, what we can see we're doing, just as we did last week with that conversion, is that we can go from 4 6, from 2/3 to 4 6, and therefore see our pattern that emerges. And you'll see the pattern is very similar, therefore, to what appears above. So we go from 4 6 to 5 6 to 6 6 to 1 and 1 6 to 1 and 2 6 to then 1 and 3 6. So it's just looking at those equivalents that are going to help you out. If you're feeling confident, you can pause the video here and have a go at this one. If not, obviously you can listen as we're carrying on. Now, this one we can see the problem we've got is we've got 8 quarters and halves. So what we should do is convert these so they're all with the same denominator. Find that equivalence. And the easiest way to do it is to think, what is the common multiple of 2, 4, and 8? Well, I can list it, can't I? I can list my common multiples. I can do 2, 4, 6, 8, 10, 12 for my 2s. I can do 4, 8, 12 for my 4s. And I can go 8, 16. Well, instantly, we can see here that our common denominator across those is 8. Our common multiple is 8, so our common denominator can be 8. And therefore, that means we can change each of these fractions that we don't currently have into 8. So our quarter will become 2/8 because we multiply our denominator by 2, so we multiply our numerator by 2. Here our half becomes 4/8 because we multiply our denominator by 4, and we multiply therefore our numerator by 4. So this time we can see that we're actually going up in this pattern of 1/8, 2/8. Well, then we need to consider, what do I do to 1/8 to get to 2/8? And that would be to add on 1/8. So 1/8, 2/8. Well, what would be 2/8 add 1/8? Well, that would be 3/8. 4/8. Well, 4/8 add 1/8 would then give me 5/8. And of course, we would also have 6/8. And that's how you can use this method of equivalent fractions and stuff to help you carry on these fraction sequences. Now, as I said, it's not actually going to be the easiest task you've ever done. This is where you need to give it a go and think logically and start to apply previous learning, because then you will get to the answer. Once you feel confident on this, you know you've obviously got section A or B to choose from. So 2 different sets of sequences. I would say if you do A and you feel confident having done A, there's no reason why, considering there's only 4 questions, you don't do a couple of B, because then that will show us as Mrs. Williams and I that, okay, yes, you get how A works, and you can then maybe have a go at some of these where the denominators are different, because it's not complicated. It's just about finding that common denominator, the same way we found common multiples. Now, when you've done that, you have your think, your explain, and your solve. So think is very straightforward in that you have to complete these sequences, see what your missing pattern is. On explain, 3 children are counting in quarters. So wouldn't need Teddy in either. And who is counting correctly. So work out each of theirs, work out who's gone right, who's gone wrong. Okay, it might be you want to do the sequence yourself first to see how it carries on. Has someone missed out a step? Have they gone wrong somewhere, or any of them wrong? It might not be that any of them wrong. If you can reason, okay, this is what you need to do: explain your reasons. And then on your solve, you've got 1/10, 1/5, 3/10, 1/5, and how can we make 4/10? Now, to make 4/10, this means that you might need to add 2 fractions here together, okay? Or it might be you look at making one of those fractions a equivalent fraction. I don't know how you want to do it, but we'd like to leave this up to you to see how you approach this. But how can you make 4/10? Something sticks out straight away, okay? But there might be something else. There might be multiple ways. Again, this is solve. Don't just go straight, well, that's the answer. You know how to explore, okay? And then what is the highest fraction we can count to? So again, if we added all those up, what would we get? So even though we haven't done adding yet, it'll be interesting to see if any of you can start to apply that. Obviously, you may come unstuck on this type of one, which if you do, that's fun. But we'll look at this at 10 o'clock. So if you have any questions, bring them along then. Obviously, any burning questions can be asked to Mrs. Williams before then. Okay, we'll see you soon.